Agri Sri Yulia Fuji. I am a presenter of my group with the paper title pyBIMstab Slope Stability Analysis to Predict Landslide Coverage Area as an effort to reduce landslide disaster risk. With my friends, namely Afsi Lisan Aulia, Fuji Lestari, Gina Almira, and Rofik Fadilah Awal. We are from the Department of Physics Education, Faculty of Mathematics and Science Education, Indonesia University of Education, Bandung, Indonesia. Before moving to the presentation, I would like to thank each committee who has given me chance to present my research, and also thank to my supervisor, Ms. Sally Ferrani, who has guided and assisted me and my friends in realizing this paper. We have created the abstract as shown and competition video on the right of this slide. This paper contains prediction of landslide coverage areas along with prediction of affected infrastructure if landslide do occur. The outline of this presentation is introduction, methods, result and discussion, and the last one is conclusion. Let's get into the introduction. Geographically, Indonesia is located at the confluence of four tectonic plates, namely the Australian continental plate, the Asian continent, the Indian Ocean plate, and the Pacific Ocean. This condition causes Indonesia as an archipelagic country that has the potential and is also prone to natural disaster. Landslide disasters often occur in mountainous areas or steep surface, especially during a long rainfall season, and have posed significant risks in Indonesia over the past 2 years. From the geoportal data Indonesia of BNPB, there have been more than 290 landslide events in Indonesia, especially in West Java. Tectonic and climate conditions from steep slopes, areas of highly weathered rocks prone to erosion. Java province is an area that often occurs landslide because the area is dominated by hills, especially during the rainy season, which adds the load on the slopes and the soil layer experience a strong decline. Landslide is a process of slope balance disturbance that can cause the movement of soil and rock mass to move a lower place so that the force that holds the soil mass along the slopes is influenced by the physical properties of the soil and the angle of shear resistance of the soil acting along the slope based on Rischianti et al. 2019. In most cases, rainfall-induced landslides commonly occur in cut hill slope involving a huge volume of soil mass with a rapid movement. The cause of landslide is the influence that causes an increase in the shear force without any change in shear strength and without any change in external conditions or an earthquake. Before looking for the extent of landslide, the slope safety factor in a critical condition must be modeled that determine the volume of unstable soil and landslide geometry in research area. The limit equilibrium method was used to slope stability analysis, which is used to solve equilibrium equation by dividing the shear mass into slices and find the factor of safety of slope area. This study will use software package named pyBIMstab that automatically generate tortoise failure surveys and perform 2D slope stability analysis by the LEM and also can evaluate non-circular surveys. Center of mass approach is the end of deposit methods to predict the runout distance of landslide material, which also characterized by the slope stability analysis. based on Firmansyah et al. This study focused to predict the runout distance of three landslide-prone areas that have public facilities, are densely populated, and have a great risk of landslide. Are the main public transportation lines that are often used in Indonesia, namely the train line that often operates settlements, rice fields, cemeteries, highways, and public facilities from being damaged in the event of a landslide in this area. By knowing the runout distance using limit equilibrium methods, using pyBIMstab and center of mass approach methods, it can be a disaster mitigation in this research area. Methods. This research is located in three places in West Java, namely Sukatani, Sidamukti, and Pasir Jambu. This area was chosen to be our research location because in the first area, namely Sukatani, it is very close to the main Sukatani-Ciganea railway line, which is prone to subsidence so that the train line could be stopped, and this is detrimental to public activities. In the second area, namely Pasir Jambu, which is a slope adjacent to the highways as well as resident houses, and if this avalanche occurs, it can hit the road and dozens of houses around the landslide area. And the third area, namely Sidamukti, where this area has experienced landslide before, so that it is prone to medium to high landslide. This location has a lot of local residents living, so it is very dangerous if an avalanche does occur. We use secondary data of soil physical parameters and cross-sectional image. The data processing stage was first carried out by taking the coordinates of the slope points based on their elevation using web plot digitizer as the first step in modeling the slope plane. This coordinates point will be downloaded the form of a Microsoft Excel file in the form of a column of X and Y coordinates to be transferred to the pyBIMstab programming language. In addition to point coordinates, physical parameters of the soil used are also needed, namely cohesion, soil density, and shear angle. The modeling is made with an entry-exit model and setting the groundwater level to make the factor safety is 1. After the factor of safety is obtained is 1, the avalanche prone zone is seen as the first step in predicting the range of landslide through the center of mass approach. Determination of the center point of this mass is done in the form of modeling so that the radius of the landslide zone coverage is obtained. From the radius, a landslide zone circle is made and it is predicted that the infrastructure will be affected by landslide at the three research locations. Is one of the regions in West Java, precisely Purwakarta Regency, which becomes one of the public transportation lines in Indonesia, namely railways. At the research site, there had previously been an avalanche that resulted in an avalanche on the Sukatani-Ciganea train line, so that the train line was temporarily unusable. After doing modeling and simulation using pyBIMstab with the safety factor is 1, which means critical, visible critical zone of avalanche marked by a red line in the image. From the result of the modeling has been predicted that the avalanche that will occur has the radius of avalanche coverage of 24.41 meters. After analyzing landslide coverage and looking at the infrastructure using Google Earth imagery, the affected areas are the most important railroads. In addition to the railway line, there are several areas of gardens and rice fields owned by residents who will be affected, and this area is some distance from the settlement. Is Pasir Jambu, Bandung Regency. It is predicted the runout distance is 88.39 meters. This distance can endanger life and property. In the coverage area, there are residential houses, cemeteries, rice fields, and roads. The result of the analysis based on Google Earth predicted that 29 buildings could be damaged by the landslide. Area is Sedamukti Pangalengan, Bandung Regency, West Java Province. This area is included in the zone of medium to high earth movement potential. Pangalengan district is the area with the highest rainfall in Bandung Regency. Based on rainfall data conducted by BMKG in Pangalengan district, referring to rainfall data in Bandung Regency, the average annual rainfall is 1.718 to 2.603 mm per year. When viewed from a geological point of view, broadly speaking, the research location is composed of old, unresolved volcanic, herbaceous, sedimentary rocks in the form of fine and coarse dacitan hamlur tufaceous breccia containing pumice and old andesite basalan lahar deposits. Sidamukti has a landslide range 60.69 meters as seen from the Google Earth. Disaster mitigation obtained through the coverage area in Sidamukti will prevent around 32 house and public facilities from being damaged in the event of a landslide in this area. So the conclusion of this paper is the application of pyBIMstab method to predict the coverage of a land zone, which allow us to analyze the amount of infrastructure affected in an effort to mitigate a landslide. This landslide coverage is combined with information contained on Google Earth, so that the amount of infrastructure that will be affected if the landslide disaster is true. This is the reference we use in compiling this paper. And this is the end of presentation. Thank you for your attention and thank you.